All right, we're going to do 7.5 quotients of radicals. Today for Algebra 2, our objectives are to divide radical expressions, divide exponential expressions, and to rationalize some radical expressions. Okay, so first up, we've got to know when a radical expression is simplified. Like, what does that actually mean? So it's simplified when there are no perfect nth powers in the radicand. Okay, so we're not going to have like the square root of 3 to the 5th because we can get some square roots out of that. Okay, so we can't have that. That's not simplified. There are no fractions in the radicand, and there's no radicals in the denominator. So sometimes it doesn't look very simple. It actually looks a little more complex, but it is still simplified. Okay, remind you of our quotient property of radicals. So as long as we have the same index, okay, so the nth root of x and the nth root of y, then if we're dividing those, the nth root of x divided by y, we can separate out and solve the nth root of x divided by the nth root of y. So we can pull them apart or we can put them together. These work both directions. Okay, then we also have the quotient property, we're going to look at it, of radicals implies. If we, this should be fixed. This shouldn't go over all of this, so please ignore that line. If we have the square root of 100 thirds, that's equal to the square root of 100 divided by the square root of 3, which is equal to 10 divided by the square root of 3, because the square root of 100 is 10. Okay, the problem is this is not simplified because we have a radical in the denominator. So this is not simplified. Then we have to rationalize the denominator. So since we have 10 times the square root of 3, we're going to multiply it by the square root of 3, okay, because it was in the denominator, in both the numerator and the denominator, because then that it just equals 1. So 10 times the square root of 3 is 10 times the square root of 3. Square root of 3 times the square root of 3 is 3. This is simplified. Okay, there are no perfect nth powers in the radicand. There are no fractions in the radicand, and there are no radicals in the denominator. So notice we can have a fraction, we just can't have fractions in the radical or under the radical sign. Okay, so let's start solving some of these. So let's look at, I'll leave that up there a bit, example 1, A there. We want to simplify the cube root of 2 twelfths. Well, first of all, 2 and 12 could be simplified, right? 2 goes into both of them. So this would become 1/6. So we've got the cube root of 1 over 6, which is awesome. We're going to pull those apart, parse them out a little bit, and get the cube root of 1 divided by the cube root of 6. Well, the cube root of 1 is just 1. And then the next one, the cube root of 6, we can't really do anything with. We could say that's the cube root of, let's see, 2 times 3, but that doesn't help us. Okay, so I'm just going to go ahead and leave it as the cube root of 6, and I'll show you why. So the cube root of 6. Okay, so notice that we have a problem. This is a radicand, or a radical in the denominator. So we have a radical in the denominator. That's a problem. So now we need to rationalize. This is what we need to do. So we're going to rationalize. It's my cursive Z. So we're going to take this 1 over the cube root of 6, and we're going to multiply it by the cube root of 6 in the numerator and the denominator. That's going to leave me with 1 times the cube root of 6. So that's the cube root of 6 over here. We're going to have the cube root of 6 squared. Notice I have a cube root and I have a square. They don't cancel yet. Excuse me. So I have to do this again, which we did the other day in class. So we're going to multiply again by the cube root of 6 in the numerator and the denominator. So the cube root of 6 times the cube root of 6 is going to give me the cube root of 6 squared in my numerator. And here I have the cube root of 6 squared times the cube root of 6. So this is going to give me the cube root of 6 cubed now. Okay, so my cube root and my cubes cancel here. Okay, so that just leaves me with a 6 in the denominator. And here I can simplify the 6 squared. So I'm going to have the cube root. 6 squared is 36. So this is equal to the cube root of 36 over 6. So I'm doing all of those things, right? We had a problem because we had a radical in the denominator, so we had to rationalize. And because it was a cube root, we had to multiply. By the cube root of 6 2 times, so that we had a total of 3 of them. Okay. All right, let's go. I'm going to draw a line here. Let's go to B. We have 18 divided by 3 times the cube root of negative 3. Okay, so we're going to apply some of the same principles we've had all along. Okay, 18 and 3 will cancel. So 18 divided by 3 gives me 6. 3 divided by 3 is 1. That's always kind of nice. So this is equal to 6 divided by the square root of negative 3. Our negative is a problem, right? We're going to bring it out as an I. So this is going to be 6 divided by I times the square root of 3. Okay, but we have a radical in the denominator, so we need to rationalize in order to simplify. Okay, so to rationalize, we're going to take the 6 divided by I times the square root of 3. Okay, so I'm just taking that and I'm going to multiply it by my denominator. Remember, the same number, and that's in my denominator. I'm going to multiply it by in the numerator and the denominator because it's just a single term. So it'll be fine. So 6 times I is 6I, and then times the square root of 3. Here we have I times I, so we have I squared. The square root of 3 times the square root of 3 just leaves me with a 3. My 2 or my 6 and my 3 here can cancel. Okay, so 6 divided by 3 is 2, 3 divided by 3 is 1. So now I have 2I times the square root of 3 over I squared, but I squared is equal to negative 1. All right, so this is going to be equal to negative 2I times the square root of 3. So negative 2I times the square root of 3. Okay, and let's move on to C. All right, in C, we still have a division problem, right? There's our division. It's just not set up like the fraction. So we can do that. So we're going to have 2 plus 6I divided by 3I. Okay, which doesn't seem too terrible, but we have to remember this I, right, here, and we want to try to, we don't want an I in our denominator either. Okay, so to get rid of that, we're just going to multiply by I over I. Seems simple enough. Okay, in the numerator, we have to distribute this I, right? So we have 2 times I plus 6I times I is going to give me 6I squared over 3I times I is 3I squared. Remember that we know I squared equals negative 1, right? We know this, so we have to apply that. So this is going to mean that this is 2I plus 6 times negative 1 over 3 times negative 1. Okay, so then that's going to be 2I. 6 times negative 1 is negative 6, so 2I minus 6 over 3 times negative 1 is negative 3. Okay, so we can leave it like this, technically. We could get the negative out of the denominator. okay, and make this negative 2i plus 6 over 3. But actually, the most common thing is going to be to split these in two pieces, since 6 can be divided by 3. So I would actually say, all right, well, this is going to be 2i over negative 3. We could say plus negative 6 over negative 3, right? Because this negative 3 goes to each term, has to be divided out between each term. Okay, so then this would leave us with negative 2/3 I, and then negative 6 divided by negative 3 is a positive 2. So negative 2/3 I plus 2 would be the best, most simplified answer there. All right, let's try some fractional exponents. Maybe if my computer will clear out for us. There we go. I'm going to say we got all black instead. All right, so then we have fractional exponents in a denominator should also be rationalized. Okay, like don't let this one freak you out. I'm going to write it a little bigger. It's pretty hard to see right there. So it's 5 divided by 3 to the 2/5 power. To rationalize this, we're going to multiply by 3 to the 3/5 power. Okay, and this is the reason that this is rationalized, okay, is if we think about this, our powers are being, when we have 3 to the 2/5 times 3 to the 3/5, when we have the same base and we're multiplying, we add the powers together. So 2/5 plus 3/5 equals 5/5, or 1. Okay, so that's how that's rationalizing those. That's taking it to just the power or the denominator of 3, because it's 3 to the power of 5/5 or to the power of 1. Isn't that pretty awesome? And then here we're just going to, in our numerator, we're going to have 5 times 3 to the 3/5 power. We don't have the same bases, so we can't do anything else. So this is it. That's our answer, except we wouldn't write the 1 here, right? We never write that 1 when we're actually done. So that's your simplified answer, which doesn't look any simpler than what we were given, but it is, because it meets those 3 requirements of no perfect nth powers in the radicand, no fractions in the radicand, and no radicals in the denominator. So it is simplified. On to the back. We are flying through these, I feel like, today. Next up, we need to rationalize the denominator by multiplying both the numerator and denominator by the conjugate of the denominator. So this is when we have binomials, right? When we have two terms, 5 plus the square root of 3 is a binomial. And this is where we're rationalizing. We're multiplying both the numerator and the denominator by the conjugate. Okay, hopefully you remember the conjugate is just changing the symbol. Here we had 5 plus the square root of 3, and the conjugate is 5 minus the square root of 3. So these are conjugates, and they apply when we have binomials. All right, so let's dive into this first one in example 3. So we have 8 minus the square root of 3 divided by the square root of 3 plus 2. So we're going to multiply by the conjugate. This is the square root of 3 plus 2. So we're going to multiply by the square root of 3 minus 2 in both the numerator and the denominator. Okay, and then we FOIL, right? Next up, we FOIL. So 8 times the square root of 3 is 8 times the square root of 3. 8 times negative 2 is going to be negative 16. The square root of 3 times the square root of, or the negative square root of 3 times the square root of 3 is going to be negative 3. The negative square root of 3 times negative 2 is going to be positive 2 times the square root of 3. All right, let's switch it up for the denominator. Okay, so again, I'm going to show you, I'm going to go ahead and FOIL so you remember why we choose conjugates. Square root of 3 times the square root of 3 is 3. Square root of 3 times negative 2 is going to be negative 2 times the square root of 3. Positive 2 times the square root of 3 is positive 2 times the square root of 3. Positive 2 times negative 2 is negative 4. All right, so the reason that we choose conjugates is because right here, negative 2 times the square root of 3 plus 2 times the square root of 3, this cancels, it equals 0. So we get rid of our radicals. There's no more radical at this point in our denominator. Okay, so let's see what we can combine. We have 8 times the square root of 3 plus 2 times the square root of 3. Those are like terms. So 8 plus 2 is 10 times the square root of 3. And then negative 16 minus 3 is negative 19. Like I said, these two terms equal 0. So we have 3 minus 4. So that's negative 1. All right, we don't want to leave that in our denominator, that negative 1, so we would apply it, right? 10 times the square root of 3 divided by negative 1 is negative 10 times the square root of 3. Negative 19 divided by negative 1 is positive 19. So there is our multiplying by conjugates. We FOIL, and then we simplify our answer. We're going to do the same thing when we have imaginary numbers. Again, we have division, so we can set it up as a division problem. 2 plus I divided by 3 minus I. This is a binomial. I have two terms. I have 3 and I have negative I. So I'm going to multiply by the conjugate of 3 plus I. If you remember yesterday doing this, right, we didn't have binomial terms. We just had monomials. So we could just multiply by the I to get rid of it. But here, because it's a binomial, it's two terms separated by an addition or subtraction sign, we have to multiply by the conjugate. And again, we're going to FOIL when we do this. So 2 times 3 is 6. 2 times I is a positive 2I. I times 3 is 3I. I times I is a positive I squared. My denominator, I'm going to go ahead and show you all those steps and prove to you that we're going to get rid of our i's. So 3 times 3 is 9. 3 times I is a positive 3I. Negative I times 3 is negative 3I. Negative I times positive I equals negative I squared. Okay. So here we have like terms, right? A positive 2I plus 3I. So that's going to equal 6 plus 5I. And then I squared, we know I squared equals negative 1. Can't forget that. So we need to put in there plus negative 1 or minus 1, however you want to do it. Here, positive 3I minus 3I, that equals 0, right? They cancel out. So we're left with 9 minus an I square again, so negative 1. Okay, so now combine like terms. We have 6 plus negative 1, so that's going to be 5 plus 5I divided by 9 minus negative 1 is the same thing as 9 plus 1, so 10. Looks pretty good, except we need to break it up like we did. Was it the front side we did that? Yes, on the front. So this applies, we're going to do 5 divided by 10, so that equals 1/2. And then we're going to do 5I divided by 10, so that's going to equal 1/2 I. So 1/2 plus 1/2 I is our answer there. All right, great job with quotients. So we will, you all did awesome. I will see you later. Have a great night.